The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Welcome to today's Advanced Design Lunch and Learn webinar. Today, we're going to be looking at an overview of advanced design. So this is advanced design providing a structural engineer's sketch from head to toe. So I'll be going over some of the main features and capabilities of advanced design today. So before I get started, can somebody just confirm in the chat or questions pane if you can hear me okay and if you can see my screen okay as well? Okay, thank you for confirming. Right, so I can see we still have a few more attendees to join the session. So I'll just allow a couple of minutes to give them a chance to join, and then we will get started with today's webinar. So I'll just give them a couple of minutes to join. Okay, so time to get started. So for those of you who have joined, welcome to today's Advanced Design Lunch and Learn webinar, where today I'll be going over the main features and capabilities of advanced design. So it'll be a brief overview of what advanced design has to offer. So a copy of this handout is also available in the handout section, where you will have access to this handout, and it also contains links to the Advanced Design Lunch and Learn webinar webpage, and also links to my contact details, whether that's on LinkedIn or my email address. So a little bit about myself. So my name is Jamil Dida, and I'm an application engineer here at Greytech. So today I'll be delivering this webinar for you guys. So apart from delivering webinars, I'm also responsible for pre-sales demonstrations, training, and also technical support, and also helping with research and development of our products. So before joining Greytech, I worked as a structural engineer in the industry for several years. and my experience ranges across many different sectors. So to name a few most common ones, so that'd be retail, educational and residential sectors. So that's from the simplest of projects, so simple beam designs, to multi-story RCE concrete structures and steel structures I have designed during my time. And I've designed all these projects in steel, concrete and timber, both to Eurocodes and British standards. So on this page there is a link to my email address, and you can also reach me on LinkedIn as well. So this webinar is also being recorded, so this will be published on our Greytech Content Center. So here, this is where we upload all of our material for you guys to have access on demand. So this includes tips and tricks from our experts, guidance and best practices on ways around, it could be around modeling or design or analysis. And also we share with you some tips related to the industry workflows in general. So please allow up to 10 working days for this webinar to be uploaded onto our content center. An overview of what we'll be covering today. So today's a very packed session with a lot of information for you guys to take in. So to start with, I'm going to be briefly looking at the Advanced Design and Revit BIM workflow. Now, yesterday's session was purely focused on BIM workflows with Advanced Design and Revit. Today, I'm going to be covering a little bit of the same details yesterday to start with, just to give you an idea of that workflow. And then I'll be going on to adding 3D climatic loads to that model, which we'll be starting with. So that will be your wind and snow loads. And then we will look to push that into the final eminent results. So we'll have a look at our forces, displacements, some of the steel results. And also I'll touch on the dynamic views, which is a very, very nice feature to have in your projects. I'll explain why when we get to that point. That will then take us on to generating reports. So we have the ability to generate customized reports, a very quick process to instantly generate your reports for all your needs. To finish off with, I'll be then looking at a typical connection design between a steel beam and a column using our integrated design modules. And then finally, we will dive into, have a look at the concrete design module. We'll be taking you through a concrete beam using the design module. So I hope you guys enjoy today's session. So it's time to get started. Okay, so here you can see that I have a portal frame, a steel portal frame, which I'm going to be taking through the various stages for our session today. So it consists of your regular columns, some purlins, and also some bracing. Okay. So with our Greytech Power Pack, I'm going to export this model to Advanced Design, and then I'm going to make some changes in Advanced Design and bring these back into Revit using Synchronisation, just so you can see how that works and how you can benefit from the streamlined workflow. So I'm going to add a purlin over the center here, over the ridge, and I'm also going to look at adding some bracing to the end bays here, and we'll also remove a set of bracing at the back, just so you can see how that process works in terms of deleted items, modified items, and new items. So over in the Power Pack, so with the Power Pack, you'll also have an option to fine-tune your models and bring them up to scratch. If you have any errors in the model, members not quite aligning, out of plane members, you can use our structural, our analytical tools to detect these errors and use any one of these tools which you have in the toolkit there to bring that model up to scratch. So over now to have a look at the BIM features. So I can either export or import and finally synchronize models with the Power Pack. So in this case, I'm going to launch this model directly in Advanced Design. So instead of exporting, I can send this through to Advanced Design to be directly launched in Advanced Design, ready for me to start with modeling. Okay, so in this case, I'm not going to generate a report, but we can generate a report, and that will give you a list of all the items which have been exported over to Advanced Design. Okay, so you can see it's directly launched within Advanced Design, so I don't have to load the model in Advanced Design using a common file. So here we can see our portal frame. Okay, so it's successfully managed to read the GTC file. And we can see our geometry in Advanced Design. Now we're ready to model our structure. So what I will do to start with is just create a purlin over the ridge here. Okay, so all ridge beam. I'm simply going to copy these members across so you can see just how quick and easy that was. So I instantly copied that across. And now I'm going to do the same for the bracing. So I'm just add some bracing onto the end bay here. And then one on the other side. There we are. And now we should just delete this bracing here. Okay. And finally, I'm going to change the section sizes of these columns. We will increase this to a 254 UC section. At the moment, it's a 254, so it's 203, 203, 52. But I'm going to increase this to a 254, 254 by 73 UC. Okay. So I've isolated all my columns, make it easier for me to work with the model. So the beauty here is you can hide and show elements using several different ways. Okay, so we make it easier for you to manage your model. So I'm going to select a 254 UC section here. Now I've increased the size of those, and let's display the rest of the structure. And now we are ready to export. But before export, I'll show you the check control command. So earlier with Revit, we saw the analytical tools. We also have the same available on Advanced Design as well. So mirroring that approach to fine-tune your models, so you can use these following tools to correct your model. So you've got the trim and extend, projection on plane, stretching to a node. So now let's send this back through to Revit. Now I'm going to save a separate file for the GTCX here. What you can do is you can save a file at each stage, and that makes it easier for you to manage changes or to undo any changes in the model. So we're making it very easy for you to track those changes and carry those through to Revit. So it's exporting the linear elements, and it's successfully written the GTC file. So now let's go over to Revit and synchronize these changes. So over in Revit, you can see at the moment we're yet to have that the ridge, the bracing on the side, and remove the bracing at the back structure. So over to the power pack. This time I'm going to synchronize. Instead of importing, it's simply a case of mirroring the models on both sides. So what we're making sure through synchronization is that that mirror is showing the same reflection on both sides in terms of your structure model in Advanced Design and also your model in Revit. So let's go ahead and load the GTCX, which we just exported. The beauty here is that you can start anywhere in this process, whether you start with a model in Revit or whether that be in Advanced Design. The process is still the same, just as smooth, just as efficient. So you can very easily get to where you need to be using our BIM export and import tools with our Power Pack. So here I've loaded that GTCX, and you can see that the changes have been broken down into a series of different stages. Or you can see the legend. We have a series of items which are new items. Okay, so 10 new items, modified, deleted objects, unchained objects. So I'm going to narrow this down, break this down into stages. So I'm not going to synchronize this all in one go. So I'm going to go from new to deleted to modified. So I'm going to just show you what this looks like. So you can expand on each element and see exactly what has changed. In this case, the host application is Revit, the GTC file is Advanced Design. So you can see in the host application value, there's no beam size there for the ridge beam, but there is one for Advanced Design. So that's saying that it's detected an initial beam. So I can choose to either keep, accept, or ignore these changes. So I'm going to accept these changes and apply them. Keep your eye on the actual the model in the model space, where you should now see the ridge beam and the bracings appear. Okay, so I'll just give it a few seconds. You should see the bracing and the ridge beam appear over there. Okay, there we are. Voila. We've instantly now carried through our changes that we've made in Advanced Design. So you can see all the changes carried through. And now the legend's been updated to show that there are 0 new objects. Okay, here we are. Just zoom in to show you so you get a better look. Okay, so now let's move on to the next stage of our synchronization and have a look at now synchronizing, taking account the changes, the deleted items. So we have 4 members which have been deleted, namely the bracing at the back. So let's choose to accept these changes. I'll just zoom in so you can keep your eye on the bracing for this that portal frame at the back there, and click apply. Yes, we want to apply the changes. You can also obviously print a synchronization report as you're going along, and that way you can keep track of all the changes that you've made in your model. Okay, so it's removed the bracing there. Now you can see the legend has been updated to show 0 deleted objects. Okay, so that's 2/3 of my synchronization complete there. If you wanted, you could do all this in one go, but this is generally a best practice to divide this up into 3 different stages, so you can see just how that model is changing to take into account those changes. So if we look at the modified objects, you can see here the host is showing a 203, 20352 UC, and in the GTC file, we changed that to a 254 UC section. So I'm just going to apply these changes now and update our section sizes. So we'll, yes, we want to apply those changes. So at the moment, there are 203, 203, 52 UC sections. Okay. So it has taken those changes into account. I'll just close this dialog box. And now let's have a look at our columns. Excellent. So we can see that our column sizes have been updated to suit the sections that we changed in Advanced Design. So you can see just how easy that process was. I was able to manage it very efficiently. On the left-hand side, we have a set of levels in Revit here. Okay, so the levels that you create in Revit for your structure, these are also carried through into Advanced Design when we export our models. So you can see you've got the same levels here. Okay, and that makes it easier for you to manage your model within those subsystems. So it's not a case of finding a needle in the haystack. Very easy to manage your model and also narrow it down to the different levels. So I'm going to create a series of climatic loads now. So let's add the interesting ones. So you can see we've got a series of loads here. We have different types of loads. You've got your accidental load, temperatures, snow, wind loads, crane loads. So let's add snow and wind loads for those climatic loads. So we have a very powerful 3D climatic generator that instantly generates 3D climatic loads on any structure. So I'm going to just enclose this in an envelope of load areas or load panels so that we can distribute those climatic forces. So let's define the extent. The good thing is with the copy dialog boxes or this extrusion command is that you can actually preview before you make the changes. So if you're not quite happy with it, you can then repeat that step again rather than having to delete it and then reproduce the load areas. I'm going to do the same now for the portal frame at the back. We've introduced a series of on selection commands here. You'll see when after creating this one, I right click and choose load areas on selection. So we have supports, your loads, your load areas. We've introduced these as shortcut commands, so you don't have to click at several points. So load areas on selection, it will detect the outline for those elements and those loads. You can do the same for the supports and connections also. So we're speeding up that modeling process for you. So we want to zoom past the modeling, and we're interested, obviously, looking at our FEM results. So we want this process to be as fast yet as accurate as possible. So in the modeling, you don't actually have to deal with nodes here as well. So it's another plus point. So you don't have any singularities. The nodes are only generating when it comes to the meshing for the results. It's purely just modeling. So let's have a look at now the wind loads here. In the properties, we have a series of settings for wind loads. So you can see you can have your CPE type, your wind speeds as well, your pressure. So for the wind speeds, we've got a nice little interactive map here. So here I can choose my location. Let's go over to somewhere in the north. Yep, so just to see that increase from 22 to 31. There we are. We select our location and it's updated your dynamic effects along with that the wind speed. Okay. And now all it is a case of automatically generating the load on there. There we are. Let's auto scale the load so we can see these a little bit better. Voila. And you can see within just a few clicks, we have automatically generated a series of wind loads on this structure. And the same applies for snow loads. So I'll just isolate the loads here, just to display the snow loads. Here you can see the snow loads. You can see the accumulation effect of the snow load with the triangulated load there between this step of the building. So I've instantly managed to create the 3D climatic loads. And now I'm going to take you over to have a look at the FEM result. So as this is an overview session, I'll just be showing you a brief overview of everything for Advanced Design. So I'm going to create a new calculation, steel FE. So I've got a model here which also has some connections in there, so I can show you that later on as well. So let's go ahead and calculate this, and you can see at each step exactly what is being checked and what is being calculated. Let's finish the checking, and it should now be going through the combination. So it's starting the distribution of loads. And the good thing about analysis is that if you run the analysis once, you don't have to keep running the analysis again and again each time you open the model. So it's just a simple case of opening the model with the results, and away you go. So now we're going into the steel design now. So it's launching the steel design. So it's calculating, carrying out all the checks, so stability checks, your bending and biaxial bending, tension, compression, so all your checks to the goes there. So it's finished the design now, the calculation of the FEM and the steel design. So you can see you've got two sets of results side by side. One is for the FEM results, one for the steel design results. I'm just going to switch off these nodes. And let's switch to a 3D view, a transparent view. So you can see the outline of the structure a little bit better. There we are. Right, back over to the results now. And here, if you notice here, what I'm doing is I'm just simply choosing the drop-down boxes to switch through the results. And once I've looked at results on the screen, I can save these as a post-processing view as well. So the save view option lets me save these results. So let's have a look at some forces. Moments. There we go. Looking at a maximum 45 kilonewtons. Let's save that view. And over to now the stresses. We'll have a look at this for a ULS combination this time. Combination 107 with the snow load, SXY. We're looking at maximum around 35 Newton per meter squared. I'll save this view as well. You can see just how easy it is to have a look at your results. You don't have to go through dozens of dialog boxes. A simple case of choosing a result type from the drop down, save your views, and away you go. So here are my deflections. The deviation allowable deflection, maximum we're looking at is 79%, and that's in the purlins there. So here's a maximum deflection in general. We can also take a look at strengths. So these are your work ratios. So you've got all your work ratios here. So whatever you want, if you want to combine bending actual forces or just a maximum work ratio. In this case, we go for the max work ratio is around 52%. We could probably do with changing some of the section sizes. So we'll save that view. We now have a series of views. So you can see on the left-hand side here, I've got around 5 views which I've saved, and I can easily switch between these results. So now back over to displacements. You can also have a look at the animation as well, which is very nice to have a look at. You have a lot of fun with this if you want to see how the structure behaves generally in response to that load or the load case. And I've instantly, all I have to do is just click between the views which I've saved, and that will switch over to the results I want to have a look at. They've got slider scale for the results and also the font size here. We get to control what these diagrams look like. Okay, so now let's just set that to small scale, back over to the stresses. Simply switch between your results. You don't have to keep selecting all the items again to look at results. It's simply just switching between the results. And the good thing also is when you perform an analysis, you have the option to update the post-processing views. So if you make a change in the model, you can choose to update those views. They will be automatically updated. So now let's have a look at the shape sheet. We're interested now in what the numbers look like and where they come from. So for this column, the maximum deflection is 54%. You've got the cross-section strengths are 52%, and you can see exactly which checks are being carried out and to which clauses. You've got the references there as well. So you can see also the worst cases. Yes, the combinations, combination 6, 28, 84, and 87 are the worst case ones for that particular check. And you've got a breakdown of also the stability, verification as well, and you can see exactly where those numbers are coming from. They're very easy to follow. So that's a breakdown of the results. Now let's have a look at optimizing the structure. So we have several items and members in here, which, for example, this purlin here, I think you can see stability is it's phenomenally high here. It's failing for those 2 verifications. Let's switch over for some ones which are failing and quite high in deflection. So what you can do is you can simply click in the box on the right hand side and choose a solution, automatic solution, or you can choose your own section size. So one click will activate the automatic suggested solution, or you can scroll through. You can also choose to accept all the solutions in one go as well. You'd accept your solutions to optimize it, you run your calculation again, and then once you're happy with it, you have your set of results. We can generate a report. So the report generator, again, is a very powerful tool. You have full control of your reports here. So I'll just empty the results I've gotten there from the previous calculation. And now I'll just quickly show you what this looks like for generating the report. So I can add in my own chapters. I'll just create a report for the views I've saved. Let's call that displacements. And let's find the results. So it's very easy to adapt this report and create the report that you want. Okay, so it can be as simple as you want, or as complex and detailed as you want. So now I'm just going to go to advanced options and just narrow the results down, because I don't want to have thousands of pages for each load case. I'm interested in just the dead load, for in this case, just the columns. Okay, to go with my view, I'll save that table results, and let's pop the view in as well. So they're the views that we've saved. The next one we're looking at is the forces. So let's add a chapter for the forces now. And over to the post-processing to now pick up that table of results for the forces. So you can see just how the results are laid out there. Very easy to find the results once you get the hang of it. We'll just narrow this down again, just to a small set, Okay, we can either do obviously columns and rafters, or everything, or just one or two items. You can see the list there. Okay, so you can take as many as you want. In this case, I'll just keep it to columns, just to keep the table nice and short and to the point. And let's add in our views. So you can see just how that looks for adding your own reports in. I'm also going to be showing you a template, so join me on Friday's session of templates. I'll be showing you some report templates which you can use to speed this up even more. So now let's add the shape sheet in as well. We can add another chapter in for the steel design, and I will then add my views which I've saved for the deflections and also the work ratio. Let's go ahead and add some of those details in. You can see all of your results for the steel available here. So your buckling checks, your maximum deflections, work ratios, all found there. I can choose also what that shape sheet looks like, and again, which elements that involves. So in this case, I'm just going to show my views that I've saved, not necessarily the table, but if we were to include the table will be the same shape sheet as we saw earlier, with all our verifications and all our biaxial bending, tension, compression, for the 6.26, 6.29 clause checks here. So that's what will be included in the report. So I'm going to generate the report so you can see what it's doing at each stage. So it starts off with Word View 97, but then that's automatically converted to a Microsoft Word document. So you can generate your report in Microsoft Word, PDF, or even an Excel sheet with your forces. Let's go over the document tab, and the good thing is that everything is integrated with Advanced Design, so we can open our Word report from here. So I don't have to go to the Explorer to find my report. Simply just open a report from here, and you can also see the list of views that I saved there as well as the image files. So let's open this report to see what it looks like. So here you can see I've started off with the displacements, the table of displacement results. There we are. Set of values there. And at the bottom I should have the displacement view which we just saved. Okay. That's that. And here is the view that we saved for displacement. So I can move that over the page, resize that, relocate it. Again, this is fully customizable, so you can add your own text in there. Also edit the reports, change the format, the fonts, the layout, exactly what you want. So you have full control over this. And then you've got the forces as well. So as an engineer, you want to be spending minimum time generating reports. Sometimes it can take a very large amount of your time updating those reports to reflect the changes, compiling those PDFs. So we've taken all that heartache away and introduced a very powerful report generator for you to instantly generate those reports and make changes. So we've had a look at the reports, and now let's have a look at connection design. So we have an integrated design module for your design of your connections. Okay, so your standard connections. So this is a typical beam to column end plate connection, but you can also design base plate connections. You've got your splice connections, pin connections, gusset connections. You've also got tubular connections. The list goes on. So just for this session, I'm going to show you this simple beam to column connection. So here, the design module, you can see these are the forces the connection will be designed for. Okay, so your actual force, shear force, and shear moment. These will need to be resisted by our connection here, and you can see it's assigned a starting point, if you like, for the connection. So a basic plate with some bolted connections there, and you can also see some welds around the section. Okay, and it's also added some stiffeners in as well. Okay, so we have a 3D interactive view here on the left-hand side, so you can see exactly what that connection looks like in detail. Over on the right-hand side, you'll see in the white workspace we have an elevation. Okay. At the bottom, we've got a section view. Yeah. So we've got a section of that plated connection. So now I'm interested in the geometry, so the plate size and my bolts. So I'll find that in geometry. So here it's here you can add in stiffeners as well. So the plate, it started off the 20mm side. So keep your eye on the diagram on the right hand side. When I enter 30mm, you'll see exactly what that looks like. So you can see the changes live before you exit the dialog box. So 30mm, okay, and that will increase the thickness of that plate. At the moment, the width and length, when it starts off with, it starts, usually at starting point relative to the section size, but you can choose an absolute value. So I've just increased the width and the length here to 300 by 900, so you can see how those changes are taken into effect. Okay, over to our bolts. So here, I get to choose my bolt size, the standard of your bolts, your grade of your bolts, and also the bolt set. Okay, so position. At the moment, we've got 2 rows, but just to show you what this looks like, I'll enter 3 rows. I'll then revert back to 2 rows. So 3 rows of bolts here. That will update in a second when I click. Here we are. That's obviously inappropriate. We don't have any bolts connecting anything on the sides there, so we'll just bring it back down to 2. And you can also change the bolt distances. So you've got 100mm of the bolt rows here. So I'll just zoom into this view on its own. And the good thing here is that you can, you've got a peace of mind here when you're defining those bolt distances, because you're fully able to design what you want, how you want it here. If you're outside the limits to maximum and minimums, don't need to worry, because it will then alert you if you're outside the minimum distance from the edges or minimum or maximum spacings, which I'll show you later when we analyze this connection. It will pick up those errors if you need to revisit the spacing. So I'll just increase the spacing and decrease the spacing there, so you can see I made some changes there. Okay. And I think those bolts are too close to the flange there. I'm expecting that to be probably too close to the welds there, so we'll see that as an error pop up. Your holes, you get control over what that hole looks like. So your round, countersunk, or slotted holes, if you have a deflection head, you're going to be allowed the beam to move in some cases. Over on our design settings, these are all your design parameters, so your safety factors, your shear planes, your design methods for your welds, and also your reduction factors. Loads and combinations. So this is where you'll find the combinations which have been carried through from the main global model. Loads definition. Here is a list of loads which this connection will be designed to resist. So these are those numbers and where they come from. And let's calculate this connection to see how this looks. I'm expecting some errors now for the positioning, and you can see it's instantly highlighted some bolts which aren't working. So you can see bolts in tension. The result is simply presented in a work ratio. So the work ratio, there we are. It goes from highest to lowest. So bolts in tension is the overriding factor here for this design. So you can see the worst case combination, which has been used to calculate that particular check. Bolt tension is pretty high there. So it's over to the errors and warnings. So you can see, here we are, connect design conflict. If I zoom in, it will highlight the culprit in red. So those 2 bolts there. I suppose the same applies to the remainder of the bolts. They're too close to the web there. I need to also revisit the tension anchor bolts. Construction conditions for positioning of holes have failed. So that is where it will calculate the positioning. So minimum, maximum tolerances. If you're outside of those, that's what that warning relates to. So if we have a look at interactive drawing, you can also generate a set of PDF or DWG drawings. Okay, so I'll just resize this view here, elevation. 120. Okay. So again, these are fully customizable drawings. I can rearrange on the page, resize section views, add in additional views. I can also load my own template into this as well. So if you have a company standard which you follow, you can load your template from the drawing template option, and you then got your very own drawing there. So I can load my template, and I can also save this as a DWG. When it then comes to AutoCAD, I simply explode the drawing, and then I can make any manual changes I want to. So again, add into that tailored, fully customizable approach. Okay, so that's a bit about the drawing there. Why not take a look at the report now? So here, see with the report, when I open the report settings, there are three main levels of report. So you've got a joint report as well, is intermediate and simplified report. So it's a simple tick box exercise. Choose what you want to include and exclude what you don't want to see in the report. Very simple there. There we go. And I'll just show a preview of a typical intermediate report, just so you can see what that looks like. Okay, so you can see that sort of information there. Very quick to generate those reports. Very quick to go from the design to the generation of those drawings, and then to also the preview of the report. So a preview of the report, see what that looks like. 1 second. So here's the report. So the report can, once again, either be generated in PDF format, or it can be also generated as a Word document as well. So in this case, here's a preview of the report for that particular connection there. And you'll see it has reference to all of your Eurocodes and clauses as well. So very easy to follow for an independent checker here, if they need to check. If you to output this as a Word document, you could also add your own calculations in there if you wanted. There we are, so a reference to all the tables. Constructive condition failed. So that was to do with the spacing. Okay, so we got bolt tension, where that comes from. So you can see exactly how it's arrived at those numbers. So you've got a hand calculated approach there to the results. Okay. Of course, I could even narrow this report down even further if I wanted, but this is a medium-leveled detail report. So I'll show you, just to show you what it looks like. So that's a steel connection there, but bear in mind you can also design base plates, footings, any other type of connections as well. So I'll now, to finish off with, I'm going to show you what the concrete design module looks like and what that has to offer. So here I have a multi-story RC building here. So this is an office building with some concrete beams, slabs, columns, and also a shear core. So in this case, I'll just show you what the beam design looks like in this case. So here you can see I'm going to open the already created analysis. Let's view the full model here. So with the design module, you can design slabs, columns, beams, shear walls as well, and also your footings. So I'm just going to start off with showing you the beams. During my the RC design session, which is on Thursday, that's when I'll be going into detail with some of the other elements. So if you're interested in any other elements, make sure you join me on that session on Thursday. So here you can see I've directly launched it once again with the design module. So no need for a third-party application to design this member. So it's almost as designing, I've gone from the global model to an individual member design. Okay. So here, so I can design them as individually, or I can also put them under groups. So I can design the worst case in that group. So here is the sizes that's imported from the main model, but I can change these at any point. So it's almost as if I'm designing a single member from scratch. So I can define those size settings. Main geometry once again. That's from the model. These are the sections. Opening. So you can add in your openings for any surfaces or depressions as well into the beam if you wanted. I can add an opening, there we go. So I get control of position of that hole. You can also add in depressions as well if you need. Open link settings as well. Okay. So that's a bit about the geometry there. Over to the design settings. So here you'll find all your design assumptions. So general design. So here's your concrete age, your creep and shrinkage settings as well, and your safety factors. In the beam design, here's where you'll find your settings for your fire resistance, your compression strut angles, and the likes. You can also change your concrete grade from here in the ductility class. There we are, A, B, or C. Let's stick with class A 2530. Here are your concrete colors. So 30 millimeters it's gone for. I can change that to 35. Okay. Deflection. So this is a method used to calculate the deflection distribution. Let's come out of that. And over to our stock settings. Here is a simple tick box of what you want to include in calculation. So you can see H16 is unticked. So it won't really take H16 into account for the design. Okay, so include every other bar. So whatever you have ticked on there, that's what it includes. So for the reinforcement settings, so here are the settings for the longitudinal bars, so the main bars, transversal bars, or for example your links or your stirrups. So you can choose an automatic definition, or you can impose your own diameter on there if you want as well. So I'll just leave that automatic. Again, shape, it's up to you if you want to have stirrups, pins, or multiple links. And you can choose your hooks as well. At the moment, this is deciding to choose a package of links, so that you have different packages. If I want to uniformly space all the links at regular centers, I can choose the uniform spacing option and enter my spacing there. So 150 millimeters, for example. I'll stick with the spacing of packages, okay, in the spacing method as well. Assembly bars, anti-crack bars. So if you have, for those deeper sections approaching 900 meter deep, it's important to have those anti-crack bars to resist the cracking on the side faces there. So you can also add in your own anti-crack bars there if you wanted. Okay, so we have the sections there. In this case, we don't really have any splice bars, but you can add in splice bars, your sliding and strut bars. You can see just how involved this is. Continuity bars, anchorage. So you've got the full design here. Okay. And the good thing is, the design that you make in the design module, you can export this design back to Revit as well using the Power Pack. So your technician or the detailer can pick up those the design that you've made for that member, and they can go ahead and start detailing based on that. They can then they can modify those cages. So all the reinforcement cages are exported across to Revit. They can then simply amend those cages as and when required. So loads of combinations. Once again, you can add in your type of loads, your triangular loads, your trapezoidal loads, point loads, just like you want. And these are some of the loads which have been calculated from the main global model. Let's calculate this beam. So if we calculate this beam, again you'll see if there are any errors and what that looks like. Okay, so here we can see it started by recommending 20 millimeter bars at the top, and it's gone for 2 layers of H10s at the bottom, 4 number. Obviously, I would bring that down, so I think the top may be too oversized. 10 millimeters at the bottom is a bit undersized, so I can change that design if I wanted. Okay. And I can take a look at the interactive view here just to see just how that interaction looks between each of the reinforcement diagrams there. So you can see just how that's arranged and laid out, see what that reinforcement cage looks like. Okay. And if I go over back to the main views, let's zoom back out, go to the main views. Okay, twist that around. We have, you'll notice that there's a slider scale on this. So if I slide that scale, that controls where that section view is taken at the bottom right there. Yeah, so if I slide that across, it will show a different view at a different point. So now let's have a look at the results here. So we need to change our ductility class from the property settings there to B or C. Work ratios. Here you can see what our reinforcement ratios look like. So at the top, actually, yeah, so at the top that's why it's oversized. You can see it's quite a lot required at the top. Okay, so that's where the moments, you can see resisting moments and the design moments. simple work ratios. Over to our result drawings there. So here you have your bending moment, shear force on that beam. You can add your actual force as well, and torsion moments if you wanted. You also have these are interactive representations, by the way, so you can choose to click at any point and it will show you what the result is at that point. So this was not showing it for some reason. Let's try it on the reinforcement. So on the reinforcement, let's open the interactive scale, and if you slide across, you can see just how that's changing across the span of that beam, what that looks like at different points. So here you can see this is the required against the provided reinforcement for this particular beam. So you can also look at the links, transversal main reinforcement there. Over to the deflection then. So you can see the limit ratio is 40.3, 40.4. Stresses, you have the crack widths, the stresses in the concrete, and also the stresses in the rebar. We haven't specified any fire resistance, only fire timing, so I will leave that. There'll probably be 0 there. Support verifications. Here are your reactions at each of the supports, so your moments and your forces. And then over to the interactive drawing, as we saw with the steel, the connection there. Again, we've got an interactive drawing which you can save as a PDF and customize as well. So once this loads, we should see a set of an elevation and some sections. Here we can see typical elevation. So you can choose what information to include on here. For example, the number of bars in diameter, or just the number of bars, so 4 number H10s, or just H10s at 150, or 4 number H10s at 150. So you can include what information you want on there. So we also have a bar bench you can schedule on the same sheet, and also on an individual sheet. So you can have schedule on a separate sheet if you wanted. In most cases, that's what we have here in the UK. In some countries around the world, they like to show on the same page. I can rearrange the sections if I wanted here. Let's save this as DWG, and then we'll take a look at what it looks like. So to finish off with, we'll have a look at that, and then the reports. So I'll just save this sheet in accessible location, and then we'll open it with AutoCAD to see what that looks like. So let's open the drawing, and here you can see the drawing has been carried through to AutoCAD, and you can explode these drawings, and then you're ready to go making all those changes that you want for this. So you've got full flexibility there. Okay. So that's the drawing there in DWG format. And now to finish off with, let's have a look at the report for a concrete beam. So again, the report setting is very similar to the steel connection. I'll show you an example of this report of this beam. So let's zoom back out so you can see the information in here. So this is quite a concise report on about 10 pages. So you've got all your assumptions, your materials, then you've got all your solicitations, so all your envelopes with all your stresses, all your checks. Here we are. So you've got your warnings there, all your deflections, your load cases and combinations. So that's a typical report for a concrete beam there. Okay. Right. Oops. So that then brings me to the end of the demonstration for advanced design. So do we have any questions? If you have any questions, please feel free to drop those in the chat box or in the question page. Equally, you can also send me an email. I'll just put my email address in the chat box so you have that there. If you have any questions related to today's demonstration or any questions in general related to advanced design, please feel free to send me a message and I'll get back to you with an answer on there. If you would also like us to set up a demonstration for yourself or your company, we can also set up a tailored demonstration according to your needs, requirements, and what you want to see. So we can produce that content for you, and those demonstrations are free of charge. So once again, send me an email if you or your company are interested in a demonstration, a tailored demonstration for your needs. We can look at booking that in the diary for you. So I'll just give a couple of minutes if we have any questions, and then I'll look at ending the session for today. Okay, so it doesn't look like there are any questions at this point, but if you have any, please make sure you send me an email and I'll get back to you with an answer to those. So just before we wrap up for today's session, I'd just like to remind you of what we have coming up later on in the week. So as part of Lunch and Learn Wednesday, so tomorrow we'll be looking at construction stages, a structural engineer's design formula. So that's a must-have for designing buildings for construction stages, especially for concrete structures. And then on Thursday, I'll be looking at reinforced concrete design. So I'll be taking you through the structural engineer's journey from analysis to design. So I'll be going through a basic model and then carrying that through to design, where I'll be going into the design of some other members. Today we looked at just beams, and that one we look at columns and slabs as well. So make sure you stay tuned later on this week. You can join me for the rest of the sessions during this week to avoid missing out on some very important information. So thank you for joining me today on today's session. Make sure to follow us on social media. So please make sure to follow us on Twitter, Facebook, LinkedIn, and YouTube, where you'll find all our latest and up-to-date tutorials, tips and tricks, news, and offers. So it's bye from me for now, and I look forward to seeing you guys on the next session. Bye for now.